Hi, I hear this is your first time. No, I really like that. I always, honestly, whenever somebody asks me to come and it's their first time, I really try to make it happen because Heidi, you were there. We did that in Israel. It's their first time. It was super cool. Everybody's a little extra nervous. Deploying that shit to prod is never straightforward. It's cool. Thanks for having me. My name is Charity. I am an operations engineer. I'm like legally mandated to report that our O'Reilly book is going to be out in 3 weeks. I've worked at all of these places and a few others, and the only good diff is a red diff. I will write code when I need to, but code causes problems, and I don't like problems, so I write as little as I have to. Also, this happened. I had a dress. I don't know where it went. Maybe there's a Lyft driver who's very happy right now. I'm not sure. But I got on the flight, and I'm like, all I had was my pajamas and my leggings, which I then spilled ravioli on. What I'm saying is I'm an adult, and I have adult problems. And then John was like, now I want a conference where all the speakers wear pajamas and there's a nap room. And I'm like, fuck yeah, why don't we have that? Oh, anyway, you guys are DevOps folks, so like monitoring, that's kind of our thing. That's kind of why we exist, right? And I hate it. I've always hated it. And at Monodrama, a year before this, Gregory had some slides that I really loved where he was saying, you know, we're still doing the same stuff that we've been doing for 20 years. We're doing it better. We're doing it a lot better. But it hasn't really changed. And it really sparked something in me where I started thinking about that. And I'm like, all right, I like to speak hyperbolically. I make big statements. They're not true. Monitoring's not dead. But what I want to talk to you today about is the ways that our systems are changing that are driving the need for new ways of thinking and interacting with them. You know, monitoring has a pretty well-defined set of best practices that we all kind of know. Like, if something breaks once, cool, you add a check for it, and you paid yourselves the next time so you can find it faster, right? And these work for a set of scenarios, and they don't work for others. Anyway, like I said, I hate monitoring. We're not a monitoring company. But I love debugging, right? strace is kind of my Lord and Savior. I love the kinds of arcane bugs that you're never supposed to have, and vendors will all tell you that you never will have. And this is kind of the theme of the talk, which is that like the complexity of the systems that we're building and maintaining and designing and supporting is exploding, right? And our tools are very much designed for a world where we know it's going to break. Monitoring, as Greg described it, is, and I love this definition, monitoring is the action of observing and checking the behaviors and outputs of a system and its components over time. So the first lesson of distributed systems is your system is never up, right? There are so many catastrophic states that exist right now that you don't know about. You know, when you walk into work on Monday and you look at your dashboards, they're all green, and you're like, yes. It's a lie. And it's a lie that kind of turns toxic with distributed systems when you start to believe that if you don't see it on your graph, it isn't true, or it doesn't exist. And I know that, all right, so like observability, and I apologize for this, but like it's the new DevOps that everybody hates, that like wants to argue about. It's fine, whatever. But observability, like as a concept, is taken from control theory. And it basically means how much can you understand about how the internals of your system and what's happening from observing the outputs, right? Your system is more observable if you can look at, you know, your graphs and understand what's happening inside of it. And the way that it's different from monitoring is that monitoring is basically for your known unknowns. Well, okay, so there's also this. This is my alter ego. I love her. So basically, what do we do about it, right, is the question. Observability is kind of a superset of your monitoring, which is, what do I expect is going to break? I'm going to check for that stuff, right? Your instrumentation, like, we're all engineers now, right? We're not operators, which means we have to get used to diving into the guts of our software and making it explain itself better to us. Monitoring is biased towards outages, right? It's biased towards things breaking. We monitor for the things that will break, but there are a whole lot of things that we need to understand about our systems that aren't about breaking. It's just about understanding. It's about putting ourselves in the shoes of our customers or our users. And I feel like, I'm going to make this statement, this is probably the wrong room to make this statement in, but I feel like monitoring is for ops and instrumentation, and instrumentation is for devs. And I don't say this meaning that these are functional roles, right? Devs should do ops should do devs. It's good. When something is a known unknown, it's an operator problem. When something is an unknown unknown, it's an engineering problem. It is an open-ended question. You don't know if it's going to take 30 seconds to figure out what's happening or 30 hours. And like, come on, we all kind of get off on that, right? the edge of your seat debugging like middle of the night, I do. I'm not supposed to admit that. People throw this term complexity around a lot, and it kind of annoys me a lot of the time because it's like they're substituting this noun for something that's real, and it's not very well defined. It does mean something, though. It does mean something real. I went down this giant rabbit hole the other night of trying to understand what complexity in software actually means. I learned about some stuff like high cyclomatic complexity. Means how many different paths there are through the system. Oh God, what was that other thing? There's like I don't remember the name. Halstead volume, how much information is in the source code? Your variables, your functions, and all this shit. It's super interesting. I'm not a computer scientist, by the way. I'm a music major dropout, thank you. I think this is why I gravitate towards things that are practical. I cannot be motivated to do things that do not have a real world need. But it's still fun to read about. Anyway, complexity, however you choose to describe it or define it, I think we can all agree that it's growing, which is why I graphed it for you, using my music major dropout sciencey skills. You can see, within a year, none of us are going to understand anything that's happening. So, complexity, architecture, like lamp stack. Most of you, I see some bald heads. Cool. We've been around since the day that the lamp stack was like cutting edge, right? This is now that Facebook has shut parse down, I can free to share basically anything. Any Facebook people here? Great. This is like a graph of our infrastructure a couple years ago. And it got complicated. It got very complicated, but it's getting more and more complicated. Honestly, I feel like the way that we need to be thinking about systems in the future is like the electrical grid. It's a great example of a distributed system. People understand, you know, there are going to be localized problems. There are going to be hurricanes. There are going to be systemic problems. There are known unknowns that we've seen before and we can check for, and there are unknown unknowns all the fucking time. So I'm going to run through just like some examples of problems, like the way we would experience them in the lamp stack era and the way we're experiencing them now. And these are all drawn from reality, and I apologize if trigger warning. Like, photos are loading slowly for some people. Why? You know, app tiers, complexity, the app tier is saturated, errors are high, it's a database. You know, it's usually pretty easy to figure out which subsystem to point the finger at, and then you go do a deep dive into that one. And then we have a postmortem. What do? We're like, oh, postmortem. I'll add a monitoring check for this outage. right? So we'll find it immediately the next time. We'll make a dashboard. Cool. These are all great ways of responding to these problems. But what about when you don't know what's happening? What about when it's like you're getting a bunch of reports? All right, here's my characteristics of the LAMP stack, monolithic mostly, health of the system, intuition friendly. It's pretty intuition friendly. Doesn't mean you don't need deep domain experts, right? You need people to go dive into the database, dive into the application code, dive into the website, the architecture. But you can identify what you need to do a deep dive into, and you attach a debugger. Fine. I have a lot of slides here, Jesus Christ. Okay, but what about these kinds of problems? Any microservices running on a C2.4XL with PyOps is timing out in this particular availability zone, but it only has a 1 in 20 chance of running slower, and it disproportionately tends to impact people who are looking at older archives on this particular shard, or the shards that have primaries in this availability zone. Or, what's this one? Oh yeah, Canadian users who are using the French language pack on a very particular version of the firmware, on a particular version of the iOS, are hitting a problem that makes it slow saving to local cache, which is why it feels like photos are loading slowly, but they will never actually surface anywhere on your backend systems. Or, like we shipped an SDK that does DB queries sequentially if the developer has enabled an optional feature flag or if the user has opted into it, which is working as intended, but we didn't let them know that it was going to be slower if they turned on the thing, right? These are all just, and like when you work with these systems, there is like infinitely long, thin tail of things that will only ever happen once or twice. You cannot predict them. And if you add a monitoring check for all of them, you will go fucking batshit. These are, by the way, all examples from Instagram. And at Parse, we had these problems where, we were doing you guys familiar with Parse, mobile backend as a service? Sweet, a couple people. So we're hosting mobile apps, right? They could upload third-party JavaScript code, and we would have to run it for them. They could write their own MongoDB queries, and we got to run it for them. It's super fun. And the problem reports that we would get were not, this query is running slowly, I will optimize it. It was like a slight uptick in complaints from around the world that sort of seemed to smell the same. Half the time, fuckers didn't turn on their Wi-Fi. It's very demoralizing. And half the time it would be one of these weird problems. We're just like, how could I ever predict that? Like, when we got acquired in 2013, I've said this before, but it's like, we had built a system with Parse that was effectively undebuggable, with some of the best engineers in the world, best tooling that the world had to offer in open source or services land, and like, regularly, like many times a week, I would get the reports, they'd be, Parse is down. I'd be like, motherfuckers, Parse is not down. Look at all of my dashboards. I have a wall full of dashboards, and they're all green. Like, go away. So, A, users don't care about your dashboards. They don't care if your shit is green. And I just lose credibility the longer I argue with them about their experience. Fun fact. What matters is the user's experience, and theirs was terrible. All right, more symptoms. I have so many symptoms. I wrote down so many use cases. I'm sorry. I still have PTSD. But these are all unknown unknowns, right? They're all unknown unknowns. And in a mature system, increasingly for all of us, they represent the majority of the things you will ever get paged about or alerted about. Like, if we're good engineers, we're not sitting here just going, oh, that again. Oh, I'm getting paged. Oh, that again. Oh, that again. Like, we don't do that, right? We remediate it, or we fix it, or we do something that doesn't wake us up in the middle of the night because we aren't fucking masochists, mostly. Characteristics of the systems that we're increasingly taking care of. They have many components, many storage systems. Like, for the longest time, the best practice was you have a database. You have the database, right? And you get to choose MySQL or Postgres or Oracle if you have money, which most of us don't, but like you have a database. And whatever the fuck you have to do with data, you just find a way to do it with the database. That's no longer true. That's no longer the best practice. And it's because we've advanced. There are now so many awesome things that we can do with data that give us a competitive advantage and that make our users more delighted. And we lose if we don't take advantage of some of those things. But it increases complexity by a lot. Microservices. I mean, I was laughing at microservices, and then I kind of just shut up because I realized I was doing microservices back at Second Life, like fucking, sorry, nobody said I shouldn't swear, so I haven't even tried. But like back in 2004, like we were spinning off services from the monolith. We were spinning off tables from the database because it's the only way to scale. And the way I think of microservices is not like, ooh, it's a fad, it's a development paradigm. They've finally attached a name to the thing that we have to do to cope with complexity, because we have to double down on it and find ways of managing it instead of ignoring it. Oh, by the way, Nathan, my coworker, is here, and he just wrote this cool article in the first edition of the Microservices Journal, and I'm super stoked about it. You should read it. It's really cool. He also like shines light in the way that we were just like accidentally, oops, we microserviced. We didn't think about it. It was fun. So we were talking about how monitoring, like for monoliths and et cetera, there are best practices that we know, right? And there are best practices that we're just starting to form, really, for microservices and these complex distributed systems. But they're different. And the reason that I think it's important to use a different term for it with observability is because I don't want to lose this really clear set of crisp best practices for monitoring that are still the same and like it's stable. Like why would you fucking trash stable, right? But we're spinning up like alpha and beta versions of like observability best practices, and they're different. And I'll give some examples. But like the best practices, rich instrumentation, right? Nothing is a black box anymore. If it's a black box, try and make it not a black box. There are ways. Events, not metrics. Sampling is key. Few, if any, dashboards. Only your KPIs. And we test in production because we have to. And very few paging alerts. That's your reward. You get woken up less. Yeah. So let's take each of those one by one. Instrumentation. We start at the edge and we work down, but it's exploratory. We don't know the answer, so we don't jump to it. I feel like jumping to dashboards in a complex system is like going to the doctor and they're like, hi. And you're like, hi, I'm sick. And they're like, cool, it's a broken leg. And you're like, no, it's not a broken leg. And they're like, it's psoriasis. And you're like, no, it's not psoriasis. Like, it's a heart attack. You're like, no, it's not a heart attack. Like, you're jumping to answers, right? You're jumping straight to answer after answer, and you're just like scanning with your eyeballs, like, is it that? Is it that? Because every single one of those dashboards is like an artifact of a past failure, some outage that you had, and you're like, I'm gonna make a dashboard so I can find it immediately next time, right? No, that's not debugging. That's not actually interacting with your systems at all. It's not asking questions, and it's not building up that rich mental model that you need. Structured data only, and events, not metrics. All right, so this is the one that's always controversial with this crowd. And I want to be clear that I'm not shitting on metrics. They're great. They're super. They're awesome. They're the most performant thing that you could ever do. But they describe the health of the system, right? They tell you about the health of the system, not the health of every event, not the health of every user's experience, not the health of every shopping cart's experience, not the health of, all of these high cardinality. Are you guys familiar with the high cardinality in this context? I'll explain it anyway. Okay, so high cardinality in this context means like, okay, say you have 10 million users. High cardinality is your unique UUIDs, right? 32 bits, unique, highest cardinality possible. Slightly lower cardinality is last names, right? You got a few Smiths, whatever. Way lower cardinality would be gender, male, female, and miscellaneous. And the lowest cardinality of all will be like species equals human, right? And the thing is that traditional monitoring metrics do not handle this at all because of the way they're stored on disk. The way they're represented on disk is every metric is an integer or a number, right? And then in order to find those numbers, we have tags. so that we can group by various things. Group by host name, maybe, if you have a few number of hosts. Group by ability, maybe. If you have, like, all of the interesting details about your system. Ability is an infinitely incrementing integer, right? Which you have to, how many of you have like done this thing where you like attach the build ID as a tag to your metrics and you have to start reaping the old ones because you ran out of fucking tags? So annoying. Metrics are great for describing the health of the system, but I would argue that the health of the system no longer matters. Seriously. Think about it. You're running in AWS, and availability zone goes down, 25% of your systems are down, and yet your users don't notice if you've architected it well. Does it matter? Fuck no. On the flip side, say you have 4 or 5 nines, and your users are complaining constantly. Does that matter? It matters way more, right? And if we're trying to figure out why they're complaining, we need to be able to break down by that 1 in 10 million, UUID, and then every combination of everything else. Fun fact, the way that Datadog monitors Datadog is every night they generate a report of like the top 50 users by traffic, and then generate dashboards for all 50 of those users so that they can look at them if they complain. So you're shit out of luck if you're number 51. It's not the right model for everything. And I feel like we have an entire generation of engineers who internalize that this is how data works, and it's not. It's how metrics work. I have examples there. I'm running out of time. I'll speed it up. I can rant about this basically forever. High cardinality is no longer nice to have. Like, I went to Monodrama for the first time, and every single person there was complaining about, ooh, it's so hard. You cannot do high cardinality. It's impossible. We did it. I mean, like, yes, we had to write our own storage engine, which you should never do unless you have to, but we had to because shit doesn't handle that. Also, think about the ways in which, like, users' requirements are exceeding. Like, they're skyrocketing. This is part of what's driving this transformation, right? They expect more and more and more out of us. And that means that we are all increasingly platforms. What is a platform other than a thing that you put other things on? Which is, sorry, dumb joke. A platform is something where you get to define more of the behavior, right? It's your queries, or it's your workload, or it's your app or something, and you get a lot more control, which is cool for the users. But for us, who are on the other side of the API, they're fucking chaos. They are chaos monkeys, human beings in general. Which is why we need to be able to see what they're doing. It's like looking for a needle in your haystack, right? Only instead of looking for a needle in the haystack, you're looking for a needle in a pile of flaming needles, and they're all just like on fire. The other thing about events is that events tell stories. Like, this works the way that our brains work. Our brains construct narrative from chaotic, like crazy, just like happenstance. Event-driven systems are explanatory, they're powerful, and if you're using containers, if you're using Kubernetes, if you're using orchestration, they're the only way to figure out what the fuck is even going on. When I say event, I kind of basically mean log, but I mean it structured. Are you guys all like on the structured data only train? Yeah? Yes? Woohoo! Structured data only, dude. Like, look, I love grep as much as anyone else here, but there are some things grep can't do. This is why we use computers, right? And structured data, dude, it's good. All right, I'm wrapping up, I swear. Dashboards. What about my dashboards? And my dashboards of dashboards to find all my dashboards with my dashboards. It's, oh God. Okay. It's fine. It's all fine. Yeah. Dashboards are great. They are. They're great. They're a hammer. They're great for hammering nails. But they're not great for screwing things in, right? Dashboards are good for KPIs. Have them. For your top level metrics, what do you want? You want latency, you want errors, you want request rate, and maybe saturation if it's relevant to your language or operating system. That's it. That's it. Everything other than that, you want to be debugging. You want a jumping off point so you can explore, so it's not just you're guessing the answers before you know the question. You know, I feel like the last generation of tools is all designed to answer questions fast, right? Your Spunks, your Datadogs is cool. If you know the question, you can find the answer immediately. And they're amazing. They're very mature. But like, I don't have those problems anymore. The problems that I have are like, I have a bunch of like symptoms are being described to me. I'm not sure if there's a problem or not. If I knew what the question was, I could tell you the answer, but I don't know what the fucking question is. This is also why you need raw requests. You have to be able to drill down to that source of truth. What actually just happened? And when you're doing pre-aggregation, right? Like you're taking time series databases. You have a second level interval. That seems cool, right? Well, you're smushing everything that happened in that second into that one fucking number. And once smushed, you cannot unsmush. Your aggregates destroy your precious detail. And in the future, like black swans are the norm. I also hate any system that doesn't let me look at maxes or mins, right? Like 99.99% is cool, but why is it lower than my average? Like, you know, it's thing that can happen. Here are some things that you can do with raw requests and math and like structured data. I do not know how anyone DBAs anymore without this kind of tooling because it's insane. You have the time series, you have the aggregates, and you have samples, right? So you see people just like hitting refresh to get the same sample again to see if the same user ID pops up repeatedly so that they can go investigate that user ID because they have 10 million, right? How do they know which one is like accidentally written a bad bot? On the other hand, when you have raw requests, what you can do is just like go, okay, sum up all the lock time that's being held in this table. Cool, what user ID is taking up the most of it? Oh, that user ID is taking 93.7% of your lock? Let's just like throttle them. It's so much easier. All right, cool. Users do not care about your system health. They don't give a shit. They can't tell. They care about their experience. And that's what we have to optimize for. Test in production, seriously. And this does not mean don't test before production. Obviously test before production. Obviously. But like Katie McCaffrey gave this great talk about how like 80% of your problems can be found with like 20% of the work. There's a scientific paper about it, so I believe the computer scientists when they say that it's true. But beyond that, when we don't acknowledge that we test in production, because we do, right? Every time you deploy the unique combination of a build ID, artifact, environment, time, that is a test. If we don't acknowledge that, we're not investing enough in our guardrails, right? All of the tools, we all systematically underinvest in release engineering. In like, what breaks systems? Well, humans break systems. Humans introduce chaos, which breaks the system. But like, canaries, how many of us have like the right amount of like, you know, not only rolling deploys, but also canary to internal, then to 1% of Brazil, right? I could be, all right, I'm gonna stop ranting. And our services, they have to have owners, not operators. This is where that engineer part comes to play, right? And software engineers need to be on call, absolutely need to be on call, because it shortens that feedback loop where you do something, it breaks, you see it, you fix it, and it's not like padded by several layers of Teams and Jira and all that shit. This is no longer optional. Like, operation skills are more important than ever. Distributed systems are all about operations. Honestly, you can round down to 0 the amount of time you spend developing a system compared to the amount of time and effort you spend operating that system over its life cycle. I feel like we're in the second wave of DevOps right now, where like wave 1 started 10 years ago, and they're like, ops people, you must learn to write code. And we're like, yeah, okay, fine, we'll write code, you know, and we do. We've done it. We've done this really well. How many of you identify as software engineers? Cool, at least 10%, maybe 15. It should be like 50, because like the next phase is, okay, software engineers, it's your turn. It's your turn. You cannot be an effective generalist software engineer if you cannot own and build operatable services, right? Understand what the fuck they're doing. And I get it, like this is somewhat self-imposed. Like we've had this martyr complex for so long that everyone's like, oh, I don't want to be woken up at 3 a.m. every day. I don't either, I'm over 30. I'm done with it. Like we all need to not accept that. Instrumentation is part of building software. Watching it run in production is part of building software. Gregory's last 2 slides were these, which will be my last 2 slides too. If we just think about distributed systems, we'll build the right things. Distributed systems for computer science is just a way of thinking about complexity. It's a way of dealing with complexity when it's gotten too big for our puny little human brains to really kind of grasp it. We can no longer fit everything about the system and how it works into our heads. We shouldn't try. It's not good. It's not good when we try. It leads to the syndrome where the person who's been at the company the longest is always the debugger of last resort. I've been that debugger of last resort. It's not a good thing, and it's disheartening to everyone who joins after you. They're like, well, I can never build up as much intuition as that person. I even try. It's time to start unpacking that. And like I said, you win way fewer paging alerts. You should only have like 4 or 5 paging alerts. A couple of end-to-end checks for your critical KPIs, latency, errors, request rate, saturation. That's it. So I think the future is going to be better. I really do. Thanks.